D-Lab, everyone. On the bench this weekend, I've got a blackface Fender Deluxe Reverb amplifier. This was a MojoTone kit build. The guy's local. He built it around 3 years ago, and he told me he's been troubleshooting it on and off ever since then, trying to get it to operate. So he brought it to D-Lab for the old magic touch. So in this video, I'll give it an initial inspection. We'll fire it up, see what the output looks like, make whatever corrections we can, and if it turns out to be more than what I'm expecting, I'll have to get with the owner, and then that will generate part 2 of the video. I also have a little gadget that I'm going to introduce in this video, something that many of you have asked for. I finally got around to doing it, right? So there's an Easter egg on the way. Alright, let's check out the Fender. Alright, let's take a look at the construction of this MojoTone kit. I like the Sprague orange drop caps. I'm not a big fan of this heavy gauge wiring that's been used throughout the build. I don't know if that was supplied by MojoTone, but for these little 12AX7s, I believe this is 18 gauge wire, and that really makes it difficult for me to take a look at the pins. Okay, but anyway, we'll cover that later. Let's just sweep the eyelet board, take a look at the solder connections. Everything looks pretty good. I'm not seeing any huge gaps, but here I can definitely see a bad solder joint right there on that 1 meg resistor. You see it moves in and out of the eyelet, so that is going to the inverter tube, which could definitely cause weak output. Okay, let's see what else we got. Everything else is looking pretty good. Once again, this heavy gauge wire really makes it difficult to see what's going on. I'm going to see if I can clean some of that up. Over here on the rectifier tube, you can see this 5-bolt feed is not really soldered too well on that pin. It's actually moving around, so I will touch that up before applying power to the amp. Okay, and down here got the 100 ohm balancing resistors. On the old Fenders, you would normally see them coming off the lamp and going to one of the studs of the power transformer. This one is going to the negative bias board, and I believe this gray wire must be the ground, going on its merry way. Alright, let's flip it around and take a look at the other view. Now we're looking from the rear of the Deluxe Reverb amp. First thing you'll notice is there's no brass grounding plate like Fender used. I'm not a huge fan of this. All your ground runners come off the eyelet board. They're soldered to the back of the pots. So you're relying on the case of the pot going to the chassis to provide ground. It obviously works, but I prefer to install the brass plate. So I'm going to see if the owner wants me to slide one of those in there. I happen to have the 10 thousandths shim stock available. So there are the 68K resistors, and once again your inputs are coming into a single conductor wire, kind of wrapping around, going on their merry way to the 12AX7s. In later Fender amps, they actually used shielded cable. I'd highly recommend, if you build any of these amps, that you don't use the single conductor wire coming off of your input jacks. Go ahead and pop in some RG174 and reduce the noise. Okay, I only saw 2 bad connections, so I'm going to repair those quickly, and then we're going to apply power and see what the signal looks like coming through this amp. So I'm getting ready to apply power to the amplifier. I've got an audio generator fired up, ready to go, my oscilloscope behind me, and then of course I need to connect a dummy load. Okay, so in the past, I'm sure you guys all remember the D-Lab amp test centers. Okay, they got a little built-in watt meter, mode switches, you can select 4 or 8 ohm operation. But those were too expensive to produce, so then I made this little gizmo for you guys. A simple 1/4 inch plug, 2 resistors, and you can select 4 or 8 ohm operation. So this was a quick, easy dummy load, okay? But some of you emailed me and said, Terry, we know you can't make the test sets, but this little guy is a little bit awkward, kind of janky, I get it, but it does a job. And they said, can you give us something in between that? So perhaps some type of a selectable dummy load that has an output at least for an oscilloscope. So alright guys, I did it, okay? The black box. What's on the other side? The dummy head, okay? So this is a 50 watt dummy load. It's got a selector switch for either 4, 16, or 8 ohm operation. Got an output here for a scope. This 1/4 inch jack here will go to the back side of your amp, okay? It's a pretty simple operation. Let's get it hooked up to the Deluxe and you can see it in operation. Alright, let me give you a little quick overview of the dummy head, okay? So there's just load resistors in here, and this switch will select whatever combination that you need for the amp that you're testing. So your output of your amplifier would go to a little patch cable to the load input on the dummy head, okay? Currently I have it in the 8 ohm position. So let me just throw this multimeter on here, you can see it. You see we've got 8 ohms, okay? Now if you say, hey, I got a Marshall, I want to do a 16 ohm output, there it is. And if you have like a Fender Champ, there's your 4 ohm output. The internal resistors in the dummy head are these Dale chassis mount type, rated at 50 watts, okay? That doesn't mean that you can fire your amp into this box and let it run for an hour. They're going to get hot, okay? So just be mindful of that. This is just for test, okay? But the dummy head's a nice convenient little package. You hook up your amp, you have access to your scope, and this is a protected output, so if something shorts on that lead, it will not affect the load resistors in the box. So let's get it hooked up to the Deluxe and give her a test spin. So we're going to set the dummy head at 8 ohm operation. Get it plugged in, speaker out. There we go. Over here, got my oscilloscope. So we'll pop him in there. While I'm running this little test, I'll have another camera focusing on the scope. So if I do see a problem and I'm over here tapping around, you'll get both views. Alright, let's check it out. So I got the Deluxe warming up. We'll start out with the vibrato channel. Scope's over there monitoring the output through the dummy head. So bring it up, you can see it over there on the scope. So she's pretty flat topped. It looks like the inverter has lost half of its signal. Now remember, I did repair the connection on this 1 meg resistor, which was actually going to the grid of that inverter tube. Let's do a little magic tap test. So nope, it does not seem to help, but I don't see anything that's sensitive either. Let's go ahead and take a look at the normal channel. See what we got going there. Yeah, nobody's home on the normal channel at all. So this amp obviously has quite a few issues. So what I'm going to do is investigate the vibrato channel first, since it seems to have some signs of life, and then I'll switch over to the normal channel. But this guy is going to require some maintenance. Okay, I believe I know why that inverter tube is not working. If you take a look right down here, you'll see a 1 meg, a 470K resistor. On the other side, there's another 1 meg resistor. This 470K resistor should actually be a 470 ohm resistor. That's why the inverter tube isn't working. More than likely, that's why the 12AT7 can't do its job. There's no current flow to the cathodes of the tube because that 470K resistor in the place of the 470 is going to restrict current. So let's change out this 470K with a 470 and see what happens. Okay, retest time. I've changed out that 470K resistor with the proper 470 ohm resistor. We're in the vibrato channel. Going to inject a tone. I have the other camera watching the scope. So here we go. Oh yeah, see there? Take a look at the sine wave now. The inverter tube is working, but is the channel, normal channel I should say, is that working now? Probably not. There's something going on there, it's just pure noise. So more than likely we've got some other wiring errors on the normal channel. I'm going to give it a quick peek, but if this is going to turn into a major deal, we're probably going to go into part 2. So the first thing that you always want to do if you have a dead channel is go to these 100K resistors and make sure that you see plate voltage. Okay, here, I'll turn off that annoying beep. I know you guys aren't big fans of that. Then you look at the cathode resistors, and this 1.3 volts is what you'd expect to see. That tells you that that tube is at least biased correctly. So my guess would be now is that for some reason the signal is not getting to that tube, or it's not leaving that tube and going where it should, which could more than likely be more wiring errors. From the voltage readings that we just saw on the 12AX7, we can assume that it is biased correctly. It's got the plate voltage and the cathode voltages are normal, so we are missing either signal in or signal out. So first off, we're going to check the input jacks. So I have this plug inserted, which opens the shorting contacts. We should see approximately 1 megohm of resistance to ground. That's feeding the grid of the 12AX7. So if I go from here to ground, I should see approximately a meg. And what do I see? A direct short. Okay? So maybe the wiper arm of this jack is not opening all the way. Let's see if that's it. Nope. How about the wiper arm of the second one? Nope. So my guess is these input jacks are wired incorrectly. I see this a lot. It is kind of a confusing operation. So let's turn the face down and take a peek at those jacks. Alright, let's take a peek inside at the wiring on these input jacks. Yeah, it's not correct. You see that tab right there? If you look at your layout diagram, you'll see that that tab is supposed to be connected to the tab right here on input 1. So this guy's turned, more than likely. This guy here is grounding out. The only way I'm going to be able to tell is to remove the jacks and take a look at the wiring. But more than likely that's what it is. They're just not configured correctly. I see this mistake quite often on these kit builds. So it looks like this is going to be a pretty time-consuming process. As usual on these kit builds, I pretty much have to go through them part by part, just like I'm building the amp, and that is what's going to happen here. I'm also going to recommend installing the brass down the front for proper ground connection, and also cleaning up the wiring, make this thing look nice. So yes, there's going to be a part 2. I'm going to have to get with the owner and see where he wants to go with this thing, but it's well worth fixing. It's a beautiful amp. It just needs a little bit of D-Lab TLC, right? So if you guys are interested in a dummy head, I have enough parts to possibly build about 10 of these units. Just drop me a line, you know how to get a hold of me. See you again.